Thank you, Chairperson. I'm Takeshi Tajiri. I'm Industry Technology Center of Nagasaki. Today, I'd like to talk about characteristic of receiving gallery mode in a Microsphere covered Antigen-Antibody layer as an Attenuated-Total-Reflection configuration. We hope the safe and reliable society. As you know, the biosensor is usually a various field to infectious disease, food pollution, and lifestyle-related disease. However, the conventional method has some problem. The culture method requires expert knowledge and a long culture time from 2 days to 7 days. On the other hand, the problem of the rapid detection method are high cost, complicated operation, and lack of sensitivity. In addition, it's like a running cost because the biochip is expensive. We support the new detection method to solve this problem. We harmonize two technologies. The first technology is an antigen-antibody reaction. This reaction has a characteristic to detect a specific solute. Here, the antigen means a pollutant. The other technology is a Microsphere resonator. For example, the Microsphere was irradiating in a certain condition. The resonance mode surrounding the navigation on the Microsphere surface was excited. The resonance mode is called whispering gallery mode. This mode is very extensive to spherical size and surface condition. From this characteristic, this Microsphere biosensor is available as an optical sensor. In this work, we evaluated the judgment time and performance. The figure shows the image. The antibody was immobilized on the Microsphere surface. Here, ds and ns were diameter and refractive index of the Microsphere. And T1 and N1 were thickness and refractive index of the antibody thin layer. We excited the whispering gallery mode for this evanescent light caused by Attenuated-Total-Reflection configuration. The resonance wavelengths, lambda 1, were decided by diameter and refractive index of the Microsphere. And the refractive resonance wavelengths were confirmed by detecting by scattering light from the Microsphere surface. The right figure shows the resonance condition after antigen-antibody reaction. Because the thickness and refractive index were increased, the resonance wavelengths to lambda 2 will get longer. In this work, we evaluated the spectral variation of two patterns. The first pattern is resonance peak split, and another pattern is resonance peak shift. In this presentation, I'd like to talk about resonance peak shift. In this experiment, I immobilized the antibody of the beta-galactose. The beta-galactose is a protection enzyme by coliform bacteria. That is a hygiene index of the food. We use a polystyrene microsphere of 10 micrometer in diameter. The carboxyl group is modified on the Microsphere surface. And the antibody were covalently bound by amide bond. And finally, the mixture solution were centrifuged, and we used only the Microsphere with the antibody. Bond of the antibody and the Microsphere were evaluated at the abundance of 280 nanometer. As a result of the measurement, the immobilized ratio of antibody was 50%. This is the optical system. This system is composed of white light, and microscope, and spectroscope. The manufactured polystyrene microsphere was placed on the cover glass. After antigen solution was dropped, the antigen-antibody reaction start on the microsphere surface. The solution was covered to prevent the drying. The single polystyrene microsphere were irradiating at the Attenuated-Total-Reflection configuration using an object lens. The polarizer was either TE or TM. As shown in the figure, the CCD image, the irradiation light size was focused. The focus light size became smaller than polystyrene microsphere. The incident position was set as the end phase of the microsphere. The end phase was the most suitable for the whispering guide mode excitation. Here, the scatter light spectra was scattered detected by a microscope. The figure shows the scatter light spectra by difference of the microsphere surface. The scatter light intensity was normalized by the maximum light intensity, respectively. In this measurement, the antigen-antibody reaction time was approximately 8 minutes, and the detection limit was 5 micrometer per milliliter. As shown in the arrow, because the adsorbate was increased on the microsphere surface, the scatter resonance light peak will shift to long wavelengths. The peak shift amount was from 1 to 3 nanometer. The peak shifts were almost agree with the theoretical mean theory. The figure shows the experiment and simulation. Upper figure, the scatter light by experiment, and under figure, the scattering cross section using mean theory by simulation. Experiment are similar to the simulation. We evaluated the variation of the absorbate on the microsphere surface. At first, as for the microsphere without the absorbate, the microsphere diameter was set to 10.04 micrometer, and the refractive index of the microsphere and the surrounding solution were set to 1.59 and 1.33 respectively. This value agrees with the commercial microsphere specification. By using this value, we calculated the thin layer. As for the antigen thin layer, the thickness and refractive index were calculated with 14 nanometer and 1.50 respectively. In the same way, as for the antigen-antibody thin layer, the thickness and refractive index were calculated with 30 nanometer and 1.50 to 1.56 respectively. Namely, the antigen thickness were calculated with 16 nanometer. This value agree with the protein specification. Here, antigen and antibody. In conclusion, the microsphere biosensor has a following characteristic. First, the adsorbate can be adjusted within 10 minutes by detecting peak splits. The second, the detection limit of the enzyme concentration is 5 microgram per milliliter. Third, the variation on the microsphere surface can be evaluated by using mean theory. In future works, the examination of the application field by changing antibody. As for the inspection equipment, the precision improvement of the resonance peak shift. Thank you so much for your kind attention.